Okay, so hello everybody, and we start consultation before exams. This is a tradition in Russian universities. And what is the main goal of this consultation? First of all, I want to explain general rules. Okay, formally, general rules for distant exams. In Russian, they are common for any exam of our department, and since you had an exam in geometry, so please follow the same rules as you had for that exam. Also, I'm not sure which system you had for that exam, so maybe I'll give you a formula for the final grade. So, let sigma 1 be your point bar system, so in general from 0 to 30, 0 if you didn't appear at all, right? So that is what you have at the moment, what you got as a result of written test, of midterm exam, and of your other activity during classes. I mean, seminar classes. Okay, then sigma 2 is equal to your grade, let's say. I'll explain what is it, times 10. Oh, sorry, times 7, right? Times 7. Yeah, so what is grade? Grade is preliminary grade for oral examination. So if you pass your oral examination, then you get a preliminary grade. So these vary from 1 up to 10. And if grade equals to 1 or 2, it means that your final grade for introduction in calculus is unsatisfactory. And 1 or 2 according to what you get during exam. So you fail in that case. Otherwise, you compute the sum of sigma 1 plus sigma 2, and according to the table, so there is a table of equivalence between final grades and what you obtain as a result. So that is $85.8. Excellent. Excellent. So 72, 78, 7, 65, 71, 6, and 58, 64, 5. That is good. 51, 57, 4, and 44, 53. That is satisfactory. Or sufficient. And then 30, 43, 2, 0, 29, 1, unsatisfactory. That is the table which is used in other mathematical disciplines at our university. So that is the system for grading for introduction to calculus in this semester. The process of exam will be recorded. Why? Since in principle you have a possibility to appeal. So if you are not satisfied by your preliminary grade, then you can appeal. Wow. I'm surprised that you don't know your preliminary score for the semester. I thought your seminar teachers informed you before. At least they sent to me your scores for the semester, so they exist. So please ask your seminar teachers if you are not informed about it. Okay? So, what is about a possibility to it's strange that you know only score for the written test. You should know for everything. So, please send an email to your teacher, seminar teacher. He should inform you, definitely. Okay, next, not next, so once again, let me explain in more details what is a possibility to appeal. So, if you are not satisfied by your preliminary grade, and you feel that in fact your answer, just your answer, nothing more, not your knowledge. Nobody will try to estimate your knowledge once again, no. So if you apply for possible appellation, so if you appeal for reconsidering your answer, then it will be watched, the record of your exam will be watched by a committee, and the committee will decide which preliminary grade is more suitable to your answer. So it doesn't guarantee to you that, it may happen that your preliminary grade after your opinion will be lower than before. Because once again, if you appeal, then a committee watch your record, your exams record, and they discuss what is more appropriate as a preliminary grade for your answer for oral exam. And after that, your final grade may be either unchanged or changed into any side. That is the rule which is used in our exams. Okay. Generally for exam, the total time for your answer should be about 1 hour. So it means that it depends on your examinator who will take your exam. So I don't know, every teacher has its own system how to proceed with those distant exams. That is a new and in some sense some alarm system. Because usual exams are all tete-a-tete, and that is why it's difficult to make very restrictive bounds for the time. Approximately, for example, concerning me, I give half an hour to a student to prepare for detailed answer. And so that is my own system, and everybody, every examinator may use another. Okay, so that is for a possibility to appeal, I explained. Next point, which I would like to mention, usually in our university, every student has a right to choose, has a right to attempt to choose as his examinator lecturer. So I am your lecturer. It means that you have a right to choose me, to ask me to take your exam. In that case, you should send me an email and let us. Okay, so deadline will be just the end of our consultation plus, let's say, half of hour, right? So if you send me an email later, then it will be not considered for sure. And of course, I don't guarantee that everybody who wants to pass his exam with, to with me. I don't guarantee that I'll accept your emails. I mean, in general, I can take an exam during a day no more than with 10 students. So it means that if there will be more than 10 students who want to pass the exam with me, then I'll need to choose criteria to accept part of those wishes and to reject others. But I don't know, it depends. So, for example, this year I had an exam in department in Russian, and no more than 7 students wished to pass the exam with me, so it was not a problem. So, okay, so in any case, you have a right to wish to pass the exam with me, and you should, in this case, you should send me email, and the deadline for those emails is half of hour after the end of this consultation. That's it. Okay? Yeah. Yeah, 30 minutes after. That is another question. Yeah, 30 minutes about questions for exam, but that is, once again, 30 minutes if this is about me personally. Other seminar teachers will be also examinators for you. So I'll create the correspondence between students and examinators. Every examinator will send you an invitation to a Google meeting before the exam. In general, 24 hours before the exam time. That's its general rules for our department. Okay? Okay, now it seems I explained all organization rules without mathematics yet, right? Okay? So, now, what's about the correspondence between program, between final exam questions, and lectures and lecture notes? Okay, first of all, I would like to mention that you have, I mean, if I would like to compare how to learn calculus analysis, so how many years? More than 40, not more than 14, yeah, more than 40, right, more than 40 years as I did, and now, so to compare, when I started calculus, practically I had only one source of information, lecture notes, which I did by myself during lectures. Or, of course, I used lecture notes from other students as well. And that's all. Mainly, that's all. There were textbooks, but I preferred just lecture notes, which were made during lectures. Of course, no videos, video record, no written lecture notes by a teacher, so it was completely different. And now you have maybe another difficulty, namely you have a lot of different sources of information. And if we are talking about just lectures in Introduction to Calculus, right, then you have at least two sources, namely lecture notes from Leonid Pankratov and other teachers, which I used mainly during my lectures, but not letter to letter. And I hope you have lecture notes which you made while you watched my lectures or records of my lectures. Of course, you have also a possibility to watch my lectures once again, but I am afraid that time is not sufficient to do it now, right? So, to make it easier, I mean the correspondence between lecture notes and final exam questions, I revised the questions. Yeah, so you see, and somebody mentioned Zorich book for second semester. What is for second semester? Let us talk about exam for the first semester now. Second semester, oh, it's ahead. Don't think about it just now. Think about exam, right? Okay, so let me try to explain the equivalence between lecture notes and final exam questions. And I'll mention if I have an essential remark concerning lecture notes, which should be where you should better to use my lectures from videos or from your own lecture notes. Okay, first question, the equivalence of two forms of completeness axiom, or the existence of the least upper bound. According to lecture notes, that is about A12 prime, and their equivalence, which is not, just it is written equivalence of A12 and A12 prime, nothing else, right? No theorem, no lemma. And so lecture notes here, it's okay. And let me mention also that is a general position. So first of all, look, there are few definitions which are completely necessary. So limit of a sequence, limit of a function, derivative of a function, okay, let be just three definitions. So, if you cannot reproduce at least one of those definitions, then you fail, for sure. So that is a necessary, completely necessary list of definitions, right? And also, if you are asked by your examiner by a question from the list of questions, right? Then you should give also every definition which is used in that theorem or in that result or in the proof. That is completely necessary. Okay, so first question I explained. Second question, the principle of nested intervals. That's important. Why? Because according to your lecture notes, there are two theorems, 1.12.2 and 1.12.3. So second question, 1.12.2 and 3. But 1.12.2 proof from your lecture notes refers to a different completeness axiom. It refers to, in fact, not to A12, but to slightly different completeness axiom. So it means if you use the proof from your lecture notes, official lecture notes, then you should be ready to prove why this formulation of completeness axiom, which is used in that proof, is equivalent to A12 from your lecture notes. It was not given in your lecture notes, so I don't know where you can find it. It is not so difficult, but it's up to you. And yeah, so I would recommend you better to use proof from my lecture 3, October 9. That is, it used A12 prime as it was given in your lecture notes. Third question, the set of rational numbers is countable, the set of points of an interval is uncountable. So third question, here are theorems 1, 13, 3, 4 and 6. Once again, in my lectures, I gave you just two theorems, which correspond to theorems 1, 13, 4 and 6. But I gave you full, complete proof of theorem 1, 13, 4, that the set of rational numbers is countable, and in your lecture notes, this proof uses a different assertion, theorem 1, 13, 3. So my proof combines those two. It means if you use lecture notes, then you should answer here just 3 theorems with proofs, not 2, as it was given in my lectures. Okay, fourth question. Convergent sequence is bounded. It's lemma 371, no problem with it in your lecture notes. Fifth question, theorems 3, 9, 2, 3. Oh, sorry, theorem 381, uniqueness of a limit of a sequence. Sixth question. I don't see any question. Is it clear everything for a while? Okay. Sixth question. 3, 9, 2 and 3. Comparison theorem and two policeman theorem for sequences. Seventh question. 3, 10, 1. That is limit theorems related to arithmetic operations. One theorem which contains several assertions for sequences. Monotone convergence theorem, 8th question. Theorem 3, 12, 4. 9th question. Number E, the number E. Okay. In your lecture notes, there is a different proof. Once again, there is no theorem. In your lecture notes, there is a part of a section. I don't remember the number of that section. And it uses binomial theorem. I didn't give you a separate question about binomial theorem. So it means that once you use lecture notes to answer the question 9 about the number E, then you may be asked to prove the binomial theorem. Because in general this is not in the program, but since you use it, you should be able to prove it. It's quite similar to Leibniz formula, but nevertheless. So if you don't like to remember binomial theorem, you can avoid it if you use here for 9th question my lecture 9 of October 30. Okay, 10th question. 10th question, the Bolzano-Weierstrass theorem, that is 3.14.3 in your lecture notes. 11th question, theorems about Cauchy sequences. There are 3 of them. 3, 15, 3, 4 and 5. Usually in analysis courses at our university and in many other universities in Russia, theorems about Cauchy sequences, they are just one theorem which includes theorem 4 as a lemma inside the proof, and 3 and 5 together. That is main result, Cauchy's criterion for sequences. So the sequence is convergent if and only if it is a Cauchy sequence. That is 11th question, in fact. But in your lecture notes and in my lectures, it is separated into 3 different theorems. That is why just 3 theorems in one question. 12th question, theorems about limit superior and limit inferior, most probably is the most difficult question in the list. Just 2 theorems, but they are quite relatively difficult, I would say, relatively difficult. 13th Question. Sequential characterization of limits, the equivalence of Cauchy and Heine definitions. Here, theorem 416. So, of course, once again, for example, 12th question. Theorems about limit superior and limit inferior. You should be able to give the definition of limit superior, limit inferior, to give also definition of upper bound, lower bound. So every notion which is used in the proof, you should be able to give an explanation. So there is a question. Tell us in which lecture we can find 12. I don't remember in which lecture. I gave you, I remember it very well. But I gave you lectures only, indication to lectures is given only when there is a difference between, an essential difference between my lectures and lecture notes. And and using of lecture notes gives you additional difficulties. That is why I refer to my lectures in several cases. In other cases, I don't refer, but of course, for every question there are references to my lectures at the moment. Thank you very much. So there is an answer to your question. Okay. Thanks. So, 13th question is given. 14th question. Cauchy's criterion for functions. That is theorem 431. 15th question. The existence of one-sided limits of monotone functions. Theorem 448. 16th. Extreme value theorem, Weierstrass theorem on a compact. 475. 17th question. Theorems 4, 7, 7 and 8. That is Bolzano-Cauchy theorem. In fact, Bolzano-Cauchy theorem is 478, but without 477 it's not sufficient. So there is an improvement, not only lecture 11 but also part of lecture 10, because that is indeed most difficult question, I would say. Okay, so 18th question. Continuity of the inverse function 484. 19th question. Necessary and sufficient conditions for uniform continuity. Here I should refer to my lecture. So that is lecture 17, 27 November. So theorems 1, 2, section 17, 2. And why I refer here to my lecture? In fact, there is a sufficient condition which is the same as in your lecture notes. If the function satisfies Hölder condition, then it is uniformly continuous. But concerning necessary condition, it is not given in your lecture note. You can say a necessary condition is just a continuity. So if a function is uniformly continuous, then the function is continuous. But that is, I would say, trivial necessary condition. And non-trivial necessary condition is boundedness of uniform continuous function on a bounded set. That was given in my lectures. And if you hate my lectures, no problem. You can use all lecture notes or another textbook. But if you use lecture notes, then concerning necessary and sufficient conditions, okay, you can give characterization of uniform continuity with what it was. Yeah, uniform continuity, how it is called. Theorem. Yeah, sequential characterization of uniform continuity, for example, theorem 4, 9, 14. I didn't give it in my lectures since I have a feeling that it can be done as a problem to solve, and I prefer to give boundedness as a necessary condition. But once again, it's up to you. You can use just lecture notes. In that case, as a necessary and sufficient conditions, you can use that theorem as well. But of course, harder conditions, that is theorem 4, which theorem 4? Yeah, 4, 9, 10 is necessary in any case. 4, 9, 10. So, theorem 4, 9, 10 is necessary. I think that is theorem 1, right? Yeah. Okay. That is about question 19. Next question, 20th question. Uniform continuity on compacts, that is theorem 4, 9, 16. You can use lecture notes without any problem. 21st. Theorem 5, 1, 4, differentiation and algebraic operations, so rules to differentiate products, ratio, and so on. 22nd, chain rule, theorem 5, 1, 6. 23rd, derivative of an inverse function, theorem 5, 1, 9. 24th, the Leibniz formula. In your lecture notes, this is example 5, 1, 14. You can use just the solution for that example as an answer, no problem. 25th, Fermat's rule, theorem 5, 2, 2. 26th, Roller theorem 5, 2, 3. Okay, 27th, 5, 2, 5. 5, 2, 5. Okay, maybe over there. 28th, Cauchy's mean value theorem 5, 2, 10. And now 29th and 30th. These are two theorems, namely 5, 4, 1 and 5, 4, 6, but In my lecture notes, they are given in slightly more general situation, namely in lecture notes they are proved only for the case of finite limits, and in my lectures, these are lecture 23, 18 December, and lecture 24, 22nd December, they were given in full generality. Okay, maybe, yeah. I will include first, so that is 8, 12 prime, the equivalence, right? Yeah, now there is the full list of correspondence between questions and lecture notes or my lecture notes. And maybe once again I would like to revise what is the difference between excellent, good and satisfactory. So to pass the exam you should be able to prove something, right? So it means that if you don't remember full proof from your question, but you may reproduce at least some essential part of a proof, and you know more or less main definitions and formulations of assertions from other questions of the program, then that is satisfactory. If you give a proof, complete proof of your question and understand it and are able to represent definitions and formulations from other parts, then that is good. And if you are able to solve some problems related to theorem of those questions, then like find some counterexamples and so on. For example, for Rolle theorem, what it was, question 26, right? 26th question, Rolle theorem. In your lecture notes, there is a full list of counterexamples which shows that you cannot omit any of suppositions. So that is an example how to discuss a theorem in details. So if you are able to do it, then and you answer other questions, then that is excellent. Okay, that is general review of the final exam program. Now, if you have more concrete questions about my lectures or lecture notes concerning those questions from the list, and of course you may ask about any question from lectures, my lectures or lecture notes which are official for us in that semester. So please ask me, I'll try to answer them. Of course, it would be better if you could answer while I presented concrete questions. and it's too late now, so if there are concrete questions, please. No questions. Everything is clear. Oof, how many proofs? It depends on the examiner. So, for instance, I can explain how I plan to ask my students who will pass the exams with me. So, first of all, I'll prepare several, we call them tickets. So one ticket will contain 2 questions. Let's say from limits and differentiation, for example, right? And then one of them I'll ask with full proof, another just to formulate, and half of hour to prepare. And after that, it depends on your answer, of course. For example, okay, you will send me your scanned answers. I'll ask you some questions, why, and so on, right, to discuss your answer. After that, it will be clear for me what is your main question, your main grade, approximately, and additional questions will be asked just to make it more clear, right? So, to clarify your knowledge of calculus. And no concrete questions. Wow, strange. Lemma corollaries. Okay, that is very important question. And of course, please ask me about concrete theorem and concrete lemma. That is what is about lemma. Concerning corollaries, in general, no. You don't need to remember corollaries. Usually corollaries are, examiner may ask you, what is about, okay, such a situation, right, which follows from the theorem, right? And of course, in that case, if you understand the proof of the theorem, you understand the assertion, then you will be able to explain what it says in that case without any problem. So please ask me more concrete. So for example, this theorem or this lemma, this corollary. So I gave you the list, right? And once a theorem is indicated, you should, for question 18. Okay, for question 18, what is for question? Do we need to prove for all kinds of interval? Yes. That is, I think it's question 18, 484. It's a good question, I remember. That is slightly, it's slightly different for lecture notes. In lecture notes it's essentially simple. So, Okay, since I indicated in the list for 18th question just theorem 484, it means it's sufficient to give just that theorem. Of course, if you are able to give more general assertion for different kinds of interval, it's good, and that is not included into the list. You see, for question 18th, just theorem 484, nothing else, right? 484. Oh. I'm sorry, I'm looking into the wrong point because questions are here and you are over there. Sorry. Okay, so for question 18, just theorem 484, just one type of interval. That's all. If you learn more, good, but it is not obligatory. Okay, more questions? No concrete questions. It's so strange. So strange. There was only one concrete question. 18, yeah, I remember that I gave you essentially more complicated proof because of different kinds of interval. Yeah. Okay, it seems that's all. Then, good luck during exam. Once again, so now 12 o'clock, it means you have half of hour if you wish to pass, I'm not sure, to answer, better to say, right? If you wish to answer the exam to me, and so you have half of hour to send me email, and then good luck for everybody.